12 flights, 0 orbital returns. Until now, a leaked FCC filing just used 4 words nobody expected. Orbital return demo. 1 document, 1 phrase, and it points to something SpaceX has never pulled off in the entire history of Starship. The launch window opens July 29th, but here's the twist. Flight 13 won't be the one. So which flight carries this mission? The answer changes everything you thought you knew about Starship's timeline. Let's start with what those 4 words actually mean. Because most people hear orbital return and think it's just a fancier landing. It's not. It's a completely different physics problem. Here's the simple version. When Starship goes suborbital, it's like throwing a ball up and letting it fall back down along roughly the same arc. Gravity does most of the work. The ship comes in slower, at a shallower angle, with less heat to deal with. Orbital return is different. The ship has to first match Earth's rotational speed. That's about 17,500 miles per hour. Then, to come home, it has to shed all of that speed by slamming into the atmosphere and using friction as a brake. That friction generates heat, close to 3,000 degrees Fahrenheit on the leading edges. Picture coasting a bicycle down a small hill versus braking a car from highway speed using nothing but the road surface. One is controlled. The other is violent, unless every single system does its job perfectly, which explains why this FCC filing matters so much. SpaceX doesn't request communication licenses for missions it isn't seriously planning. And the filing didn't say test flight. It didn't say suborbital hop. It said orbital return demo. That's a company telling a federal agency, in writing, that it intends to bring a vehicle back from real orbital velocity. Not simulate it, not approximate it, do it. The timeline. Nobody expected this soon. So when does this actually happen? The filing gives us a window. It opens July 29th and runs through late December. That's a 6-month runway, which sounds vague until you line it up with something else. Gwynne Shotwell, SpaceX's president, already confirmed Flight 13 is targeting a July launch. But she was also clear about what Flight 13 is not. It's not going to orbit. It's another suborbital shakedown of the V3 vehicle designed to prove out fixes before anyone risks a real orbital attempt. That leaves one number standing out from the crowd. Flight 14. Think about that for a second. A program that spent years working through 12 flights, some of which ended in fireballs visible for miles, is now within 1 or 2 flights of attempting something it has never done before. Not tested. Never done. And the hardware isn't hypothetical. Ship S-41 was already nearly fully stacked by the end of May, just waiting on flap installation. Booster B-21 was still receiving major sections, with its primary fuel tank segments expected to arrive by late May, and its liquid oxygen tank following in early June. That put the booster roughly 1 to 2 weeks from being fully stacked. In other words, this isn't a plan sitting in a PowerPoint deck. It's metal on the ground in Texas, right now, being assembled toward a specific mission. But there's a catch. There's always a catch with Starship. Flight 14 cannot happen if Flight 13 fails to prove itself. Everything is stacked on that one flight succeeding first. Flight 12 left behind a list of problems SpaceX has to solve before anyone trusts this vehicle with an orbital attempt. A Raptor engine failed shortly after launch. Coolant leaks affected performance during the mission. The boostback burn, the maneuver that turns the booster around and sends it home, behaved irregularly. A delayed landing burn ultimately doomed the recovery attempt. None of those are minor footnotes. Each one represents a system that has to work flawlessly during an orbital return, where the margins for error shrink dramatically. An engine issue on a suborbital hop might mean a rough landing. The same issue during an orbital re-entry, at higher speed and higher heat, could mean losing the vehicle entirely. So Flight 13 isn't just another test. It's an audition. SpaceX needs it to demonstrate stable engine performance, a clean boostback, and a controlled landing. If it delivers that, Flight 14 stays on schedule. If it doesn't, the whole orbital return timeline slides, possibly by months. That raises an uncomfortable question. Is SpaceX moving fast because the hardware is finally mature? Or is the company racing a self-imposed deadline while still chasing down basic reliability issues? Both things can be true at once, and that tension is exactly what makes the next few months worth watching closely. The forgotten milestone. Why nobody's talking about the catch? Take a step back for a second, because the orbital return headlines have buried something else. There's a second milestone quietly waiting in the wings, and it's been absent for far longer than most people realize. The last time SpaceX successfully caught a super heavy booster out of the sky was Flight 8. That was more than 15 months ago. 15 months in a program that used to make headlines every few weeks is an eternity. Since then, SpaceX has redesigned the booster almost from the ground up. It's called V3, and it's not a minor refresh. It's built specifically to make the catch safer and more repeatable. Consider the grid fins. The old design used 4 smaller fins. V3 uses 3 larger, stronger ones, mounted lower on the vehicle to avoid the worst heat during hot staging. And here's the clever part. The catch points aren't separate hardware bolted onto the booster anymore. They're built directly into 2 of the fins. Fewer parts means fewer things that can break, less weight to carry, and better force distribution when the arms close around it. On the ground, Mechazilla has changed too. The chopsticks are shorter now, which sounds like a downgrade until you realize shorter means more agile. They've swapped hydraulic actuators for electromechanical ones, which respond faster and need less maintenance. And the arms now open wider and start closing earlier in the sequence, which effectively makes the target bigger while the system gets more precise at the same time. It's the rocket equivalent of widening the goalposts while also training the goalkeeper to react faster. Why does any of this matter if the internet's attention is on orbital return? Because Elon Musk has said ship catches, meaning catching the upper stage itself, likely won't happen until SpaceX has 2 nearly flawless ocean landings under its belt. Flight 12 may already count as one of those. If that's accurate, only one more clean landing stands between SpaceX and its first attempt to catch the ship. But most engineers watching this program believe booster catches have to come back first. The booster is a brute. It's built to survive violent launch forces, so it can absorb a rough catch attempt. The ship is fragile by comparison. Its heat shield, flaps, and thermal protection system leave far less room for error. Master catching the tough vehicle first, and the fragile one becomes far less risky to attempt. So somewhere between Flight 14 and Flight 15, don't be surprised if a booster catch attempt shows up with almost no warning. SpaceX doesn't usually announce these moments in advance. It just does them. The bigger picture. Why this isn't just about one rocket. Now here's where this story gets bigger than Starship. Every rocket in history, including SpaceX's own Falcon 9, has thrown away its upper stage after launch. Falcon 9 lands its booster and reuses it, which is already remarkable. But its upper stage burns up or falls into the ocean every single time. That's still, fundamentally, a disposable rocket wearing a reusable rocket's reputation. Starship is trying to break that pattern completely. Reuse the booster. Reuse the ship. Fly again within days, not months. That's the actual goal hiding behind all these individual milestones. Orbital return isn't the finish line. It's one checkpoint on the way to something closer to how an airline operates a fleet of planes, except this fleet flies to space. And that comparison isn't just marketing language. Consider what happens today when a rocket completes a mission. Recovery teams retrieve it, transport it, inspect every system, refurbish parts, and only then does it fly again, often weeks or months later. SpaceX wants that entire process compressed into days, maybe eventually hours. Land, inspect, refuel, fly. If that sounds close to how a commercial jet turns around at an airport gate, that's intentional. In short, that's the model. Put a pin in that airline comparison, because it changes how you should read every Starship update from here forward. SpaceX isn't just building one rocket right now. It's simultaneously reshaping its entire launch infrastructure to support what full reusability requires. Out at Vandenberg Space Force Base in California, the Space Force just demolished Space Launch Complex 6, a pad originally built decades ago for a canceled military space station program and later reworked for shuttle launches that never happened there. SpaceX is turning it into a second West Coast Falcon launch site, aiming to eventually support up to 100 launches a year from Vandenberg alone, including regular Falcon Heavy missions. Colonel James Horn, who commands the base's Space Launch Delta, called it building on 6 decades of American innovation. Strip away the ceremony in that language, and the practical translation is simple. SpaceX needs more places to launch from if it's going to fly this often, this fast. Why mention a Falcon 9 pad in a Starship story? Because it tells you something important about the company's mindset. This isn't a business chasing one headline moment. It's building the surrounding infrastructure for a future where rapid, repeated launches are just routine Tuesday operations on both coasts across multiple rocket families. And there's a second thread worth pulling on. Falcon Heavy, the same rocket family getting more launch capacity, is scheduled to carry Astrobotic's Griffin 1 lunar lander to the Moon later this year. This isn't a small science probe. Astrobotic's own CEO called it the first infrastructure-class lander headed to the lunar surface, meant to become a literal cornerstone for a future moon base. It's carrying a rover, precision landing systems, and payloads from 6 different nations. Put these two facts side by side. While SpaceX chases the hardest engineering problem it has ever attempted with Starship, it's also quietly expanding the exact launch infrastructure that will carry humanity's next steps toward the moon using its existing rockets. One program is the ambitious future. The other is the reliable present, funding and enabling that future. Neither works without the other. The twist nobody's talking about. Now put the pieces together, because this is the detail that should change how you're thinking about the entire situation. Everyone is treating the orbital return demo like the hard part. It isn't, not really. The hard part already happened, quietly, over the last year and a half. Every one of those Flight 12 failures you just heard about wasn't a setback. It was a data point. Most casual observers watched those moments and saw embarrassing explosions. Engineers saw exactly where the old design broke down. Booster V3's redesigned grid fins, integrated catch points, and upgraded Raptors aren't guesses. They're direct responses to specific failures that happened in public, on camera, in front of millions of viewers who assumed they were just watching rockets blow up. So when the FCC filing says orbital return demo, it's not describing a leap into the unknown. It's describing the payoff for 18 months of very public, very expensive trial and error. The question was never whether SpaceX could reach this point. The company has a well-documented habit of eventually solving the problems it sets for itself. The real question is timing, and whether Flight 13 proves the fixes actually worked before Flight 14 puts them to the ultimate test at orbital velocity. That's the tension sitting underneath every headline about this filing. Not will SpaceX ever pull this off, but will it happen on the schedule the company just told a federal agency it's planning for? The pieces line up. The hardware's real. Now we watch Flight 13. Thanks for analyzing this with me. Like, share, comment, and subscribe to the Space Brief. More breakdowns waiting on screen.